History, it often remembers the inventions, right? But behind literally every great invention are extraordinary people.
You know, artificial intelligence was absolutely not created in a single laboratory. It was built over generations. We're talking mathematicians, scientists, engineers, and just dreamers who truly believed machines could one day learn, reason, and actually understand the world. What we're diving into today in this explainer is basically the story of a 70-year scientific relay race. So, the very first people to hold the baton in this race, they were the theoretical dreamers. Back in 1936 and 1950, the brilliant British mathematician Alan Turing laid the whole intellectual foundation of computation. He asked what is probably one of history's most profound questions: can machines think? And to figure that out, he proposed the famous Turing test. But look, to truly process information, computers needed a mathematical alphabet. Well, Claude Shannon provided exactly that. He showed that information could be represented purely in binary, just zeros and ones. So with the math and the philosophy in place, John McCarthy and Marvin Minsky organized the legendary Dartmouth Conference in 1956. McCarthy actually coined the term artificial intelligence right then and there. And alongside Minsky's boundless optimism, they essentially birthed the science. They figured, hey, if humans can think logically, we can build machines to do the exact same thing.
Okay, let's dive into this, because in 1957, a researcher named Frank Rosenblatt took an entirely new approach. He introduced something called the Perceptron. This was, literally, humanity's first real attempt to build a digital brain. Instead of relying on cold, hard mathematical logic, researchers decided to try and imitate the biological human brain itself. So loosely inspired by actual biological neurons, the perceptron could recognize simple patterns by adjusting mathematical weights while it trained. And this created massive excitement. The idea that computers could actually learn from examples rather than just blindly following manual rules. I mean, it led some folks to predict that human-level AI was just a few decades away.
But as we know, every great story has an antagonist. And ours arrived with a freezing chill in the 1970s. That early optimism, it hit a massive, unforgiving wall. The harsh reality was that computers back then simply didn't have the memory, the data, or the processing power to make these neural networks work at any kind of scale. Progress slowed badly. Governments completely slashed their funding. In fact, a lot of people in the scientific community believed AI had just completely failed. This brutal period of disappointment and widespread skepticism became known as the AI winter. And actually, a second winter followed in the 80s, when traditional systems built on expert rules ended up being just way too expensive and difficult to maintain. So how do you escape a winter like that? Well, AI needed a profound philosophical shift. See, traditional computers and early AI relied on human experts literally manually writing out explicit instructions and rigid grammar rules. But the real world is messy, isn't it? It's ambiguous, it's flexible. So by the 1990s and 2000s, as internet data exploded and computing power really started to improve, researchers completely changed their approach. They passed the baton to machine learning. This was a total game changer because it allowed machines to learn directly from massive amounts of examples, completely bypassing the impossible task of writing a manual rule for every single situation in existence.
Now, during the absolute darkest days of those winters, the broader scientific community completely dismissed neural networks. I mean, they were basically a joke to many. But someone had to keep the faith. A researcher named Geoffrey Hinton, who you might hear referred to today as one of the godfathers of AI, he just refused to let neural networks die. He kept researching them, pushing through profound isolation, crazy skepticism, and massive funding droughts. He firmly believed, deep down, that this approach would eventually succeed. And Hinton wasn't alone in this pursuit. Together with Yann LeCun and Yoshua Bengio, this trio pioneered what we now call deep learning. Yann LeCun developed something incredibly important called convolutional neural networks, or CNNs. This breakthrough allowed computers to automatically learn visual features without needing a single handwritten rule. Fun fact, this is literally the foundational math that allows your smartphone to recognize your face today. Meanwhile, Yoshua Bengio was making monumental contributions to explaining how these networks can actually learn increasingly abstract patterns from raw data.
But here's the catch. To train these deep, complex networks, researchers needed data. And not just hundreds of examples, we're talking millions. Enter a brilliant researcher named Fei-Fei Li, who led a massive project called ImageNet.
ImageNet provided millions of carefully labeled images across thousands of categories. Think of these millions of images as the essential textbooks that the neural networks desperately needed. ImageNet essentially gave AI its very first real visual education of the world. Without this massive data set, the deep learning revolution simply wouldn't have had the fuel it needed to ignite.
With that data and deep learning combined, the relay race exploded into an absolute sprint. In 2012, a neural network called AlexNet, which was actually developed by Geoffrey Hinton's students, completely dominated an image recognition competition. The AI community instantly realized, wow, deep learning truly works. Then, jump to 2016. Demis Hassabis and his company DeepMind proved that AI could master tasks we once thought were uniquely human. Their system, AlphaGo, actually defeated the world champion in the insanely complex game of Go. And just a year later, the next monumental leap arrived.
Now, what's really interesting about this slide is that in 2017, the most important breakthrough of the modern era arrived. Researchers at Google, including Ashish Vaswani, published a legendary paper called Attention is All You Need. They introduced the transformer architecture. See, previous language models had to process words sequentially, just reading one by one. But transformers use this brilliant mechanism called attention. It lets the machine evaluate the relationships between many words simultaneously. It's kind of like being able to read the whole room all at once, understanding the context of an entire paragraph instantly, instead of just reading word by word. This breakthrough literally unlocked modern text generation and reasoning.
So, the final sprint to the technology we have today required a perfect storm, advancing the architecture, scaling it up, and crucially, keeping it safe. First, you advance the architecture with transformers. Next, you scale it up. Ilya Sutskever, who, by the way, actually helped build AlexNet years earlier, played a central role at OpenAI in taking these models and scaling them with absolutely massive amounts of data and computing power to create the GPT models. But as these systems grew astonishingly powerful, alignment became absolutely critical. Researchers like Daryl Amodei co-founded Anthropic to focus heavily on safety research, making sure that these massive, complex systems remain helpful, honest, reliable, and most importantly, safe for human use.
The final piece of the puzzle was expanding this incredible technology out of the research laboratories and into the real world. A huge part of this was education. Andrej Karpathy became one of the world's most respected educators, taking these wildly complex deep learning concepts and making them understandable to millions of developers and students globally. At the exact same time, technology leaders and entrepreneurs like Sam Altman played a crucial role in bringing generative AI directly to the public through intuitive tools like ChatGPT. It's important to note he didn't invent GPT, but his leadership created the moment when a 70-year cumulative scientific achievement finally landed right on the smartphones of billions of ordinary people.
As you can see from this explainer, the history of AI is not a straight line of success. It's a deeply human story of optimism, failure, persistence, and incredible breakthroughs. The most important discoveries often happened after decades of bitter disappointment. Today's unbelievable systems, like ChatGPT and Claude, stand firmly on the shoulders of every single discovery that came before them. Artificial intelligence was never built by one genius. It was built by generations of extraordinary people who refused to stop asking impossible questions.
But before we can truly understand these intelligent machines, we first need to answer a deeper, much more profound question. You see, modern AI systems recognize statistical patterns in enormous amounts of data. They predict useful outputs and simulate intelligent behavior incredibly well, for sure. But they do all of this without human consciousness, without emotions, and without self-awareness. So, if a machine can reason and solve problems without experiencing understanding in the human sense, what is intelligence? Join us next time in our next explainer as we explore the very nature of intelligence itself.